Now, in continuation of what we have started in the previous class, normal distribution, in this class as such nothing new we are going to learn. We are just going to practice a couple of examples additionally just to take the matter ahead where we have left in the previous class. So let us directly move to examples over here. Similar type of examples what we have covered in the previous class, but yes, each example will bring forward something different, and that is what you have to learn and understand. Example 2, it says the returns of a stock are normally distributed with a mean, that is mu, of 20% and standard deviation of 5%. What is the probability that the returns will be between 15% to 20%? What is the probability that the returns will be up to 15%? And what is the probability that the returns will be above 15%? So what we do is, we first of all take up the requirement, that is the probabilities that the return will be lying between 15 to 20%. So if a stock's return during a particular period is expected to be 15% with a mean of 20% and a standard deviation of 5%, first let us compute the Z score or the Z value. So Z value is coming to exactly -1, that is x minus mu divided by sigma. Now you should understand one thing, that -1 is not the conclusive answer over here, it is just the Z score. But what lies as a skill set for you is to correctly identify the required area under the normal curve. Now look at one thing, for the returns being equal to mean, that is 20%, the Z value will be 0, we know that already. And for returns to be 15%, the Z value is coming to -1. If the returns are expected to be between the range of 15% to 20%, it is obvious that the returns must be having their coverage between 0 and -1 within this area under normal curve. In simple words, if you know that area from 0 to -1 will be actually same as the area from 0 to 1, because the curve is symmetric to the center, and we know for a gap of 1 standard deviation either side, the probability is 34.135%. So we know one thing, that the area between z equal to 0 and z equal to -1 is given as 34.135%. Therefore, the probability that returns will be between 15% to 20% is 34.135%. Let us move ahead to the next part. Now we have to compute the probability that the returns will be up to 15%, means the returns will be 15% or less. Now we have already observed one thing, that the Z value for 15% return is -1, as we have computed earlier. So let us look into the area under normal curve that will be favorable for us. So 0 and -1. In the previous part of the question, we have identified the probability of the returns between 15% to 20%. So for 20% the Z value is 0, and for 15% the Z value is -1. So the probability that the returns will be between 15% to 20% is this particular area, which indicates a probability of 34.135%. This is what we have seen already. Now the question is demanding something different. What will be the probability that the returns will be up to 15%? Means the returns will be either 15% or less. That means the area that we have to consider will be this particular area on the left, that is left to the Z value being -1. So we know one thing, that area between Z equal to 0 and Z equal to -1 is given as 34.135%, and the left tail, if you observe extreme left tail, so area from Z equal to -1 to the extreme left tail will be 50% minus the area of this strip. Let me explain this point to you again. We have seen this already earlier, that if you take the center, that is 0, and move on to the extreme left, the total area from 0 to extreme left tail is what? 50%. and the area of this strip is basically 34.135%. We want only this area to the left of -1. So that will be from the total probability of 50%, you subtract 34.135% and what you get is 15.865%. So this is the area that we wanted, that is the probability of returns up to 15% will be 15.865%, and that is what you can conclude. And one simple thing is, if the probability of returns up to 15% is 15.865%, so the probability that the returns will be greater than 15% will be 1 minus this probability. So the probability that the returns will be above 15% will be 1 minus 15.865%, that will give you 84.135%. So this will be the answer for the second and third part. Now what I can show you is an alternate way of approaching this calculation for finding the probability that the returns will be above 15%. So Z value for 15% will be -1, we know it already. So we plot that on the normal curve. This is -1, right? So basically anything which is above 15% is acceptable, and for 15% the Z value is -1. Above 15% means area to the right side. Area to the right side means this particular area where the area of this strip is 34.135%, and we can conclude that 34.135% is the area between Z equal to 0 and Z equal to -1, but we want this entire area. Now we know one more thing, that the area from 0 to extreme right tail will be 50%. So if you observe, this entire shaded region is what we are seeking, that is returns above 15%. You may aggregate these two and conclude that the cumulative area will be 84.135%. Therefore the probability that the returns will be above 15% is 84.135%. So I am sure you have understood this whole thing. Let us move ahead and take up another example. Now this example, it is similar to the one that you have attempted, but I am not going to guide you on this. You think and work it out on your own. I'll give you exactly 10 minutes to write up the calculations. I would suggest that do it as part of your rough work, and when I display the solution on screen, that is the time you should write up the whole solution in detail. Let us see whether you could answer it correctly or not. So probability that the returns will be between 10% and 15%. So first of all, you will have to work out the Z value for 15%, where Z value for 15% obviously will be -1. In the previous question also we have worked it out. Now we need to find the Z value for 10% return. For that, X value will be 10%. So X minus mu divided by sigma would give you -2 as the value of Z. Let us move ahead and we plot the area under normal curve. Our target is the range between -1 and -2. That region, that is this particular region, we want -2 to represent the returns of 10% and -1 is representing the returns of 15%. Because we want the returns between 10% and 15%, it is the region between -2 and -1 which we are targeting, and that will be 13.59%, because the shaded area, we have seen in the previous class that if it is absolute difference between -1 standard deviation and -2 standard deviation, the area under normal curve which reflects the probability of that occurrence will be 13.59%. So we know that the area will be between Z equal to -1 and Z equal to -2. So we can conclude that the probability that the returns will be between 10% to 15% is 13.59%. Let us move ahead, and now what we do is we answer the later part of the question which demands probability that the returns will be 10% or less. So the probability of returns up to 10%. Now what we have already seen, the Z value for 10% returns, it is -2. So the area under normal curve for this particular value Z equal to -2, the area below that will represent the probability that the returns will be up to 10%, because -2 is the limit for returns up to 10%. In other words, this shaded region is what we want to find out. It is very simple. We know the area of both of these strips, correct? Area of this strip as well as area of this strip we have worked out in earlier questions. Look at this. Both of these areas are known, 34.135% and 13.59% respectively. We also know one thing, that from 0 to the extreme left tail, the area is 50%. So from 50%, if we subtract this gray area, we will be getting the balancing area as this required area. Therefore, we can conclude that area between Z equal to 0 and Z equal to -1 is given as 34.135%. Between Z equal to -1 and Z equal to -2 is given as 13.59%. So the area from Z equal to -2 to extreme left tail, that is this particular area, as I told you, it will be the total area from the value of 0 to extreme left tail, that is 50%, and from that subtract this entire gray area. So it will be 50% minus 34.135% minus 13.59%, which would result into 2.275%. Therefore, the probability that the returns will be 10% or less equals to 2.275%. So in the whole scenario, if the probability of returns up to 10% is 2.275%, you can simply say what will be the probability of the returns above 10%. So the probability that the returns will be above 10% will be simply 1 minus this 2.275%, or you can call it 100 minus 2.275%, whatever. On absolute value we call it 1, by percentage we call it as 100%. So the probability that the returns will be above 10% will be 1 minus 0.02275, or you can call it as 1 minus 2.275%. The final result will be 97.725%. To compute this particular probability, that is the probability of the returns above 10%, we can follow an alternative approach as well. Let me explain what will be that alternative approach. Simple thing is, this gray area that we already know, correct? Returns above 10% means from Z equal to -2 to extreme right tail, right? So this entire gray area plus the area to the right part of the curve, which is 50%. So if I add 50%, 34.135% and 13.59%, I will be eventually getting 97.725%, correct? So we can present that alternative calculation this way. So you can write alternatively, probability that the returns will be above 10% can be determined as, we can take the Z values for -1 and -2, that is Z values for returns of 15% is -1 and for returns of 10% is -2, and when you plot these values in the normal curve, you know the areas, these both areas are known. Now we want the probability that the returns will be above 10%. For 10% returns, the Z value is -2. So this is the benchmark, -2. Above 10% means the whole area up to the extreme right, correct, is above 10%. So from Z equal to -2 to extreme left, if you go, it will be the probability of returns up to 10%, that is returns of 10% or less, but we want above 10%. So that means everything from Z equal to -2 to the extreme right, that means this area plus this later part that is 50%. Aggregate of all these will give you the required probability, and we can sum it up and conclude that probability that the returns will be above 10% is 97.725%. Let us move on to the next example, that is example 4. It says the returns of a stock are normally distributed with a mean, that is mu, of 20% and standard deviation of 5%. So I am just bringing the same data again and again. What is the probability that the returns will be between 15% to 25%? Now, by far, dealing with the same scenario again and again, you would have started picturizing that the midline where z equal to 0 is representing the mean returns, that is 20%. Because the standard deviation is 5%, if I go one standard deviation below, it will be 15%. If I go one standard deviation above, it will be 25%. That is, from 20% as mean, one standard deviation below and one standard deviation above will be the range from 15% to 25%. Going one standard deviation below, it is 34.135% as probability. Now you would have remembered this, right? And going one standard deviation above, from the center, one standard deviation above, the probability is 34.135%. So the probability for the mid region, that is where z equal to -1 to z equal to +1, that mid region probability will be aggregate of 34.135% and another 34.135%, which will be 68.27%. So verbally you can answer it, but yes, in exams you will not get a repetitive question like this. So it is just about the the right area that you have to identify in the normal curve, and accordingly you can trace the required probability. So let us write up the solution for the same. Probability that the returns will be between 15% to 25%. So we will compute the z value for both 15% and 25%. The z value for 15% is -1 and for 25% it is +1. Let us move ahead, and now we would simply plot the required area. This is the center, this is -1, this is the probability from 0 to -1, and we conclude that area between z equal to 0 to z equal to -1, it is 34.135%. On the right side, it is another 34.135%, correct? And the cumulative area, because -1 represents 15% returns, this one, -1 represents 15% returns, +1 represents 25% returns. So the probability of returns being between 15% and 25% will be this entire shaded region, which is aggregate of both of these percentages, and the cumulative area therefore comes to 68.27%. So final conclusion, that the probability of returns being between 15% to 25% will be 68.27%. So please write up this whole thing. That will be end of this solution as well as end of this particular session.